Alright, you guys let me know if you like my face in there or not. We'll take a vote later. Alright? Um, I took it out for now. Here we go. State the domain and range. One, you can graph the function in your calculator. Okay? State domain and range is the biggest thing for me right now. Let's draw a quick sketch. I can draw a quick sketch without using the calculator. Alright, what is this, a growth or a decay? A is greater than 0. Okay, good so far. And 3, that's greater than 1, so we're in a growth. So, a normal growth looks like this. Did this thing translate at all? No, because it doesn't have an x minus h plus k. So it didn't move up and down. It didn't move left and right. It's just something that looks like this. Okay? What is the domain of something that looks like this? Domain is everything, all real numbers. What about the range? Look at the picture. It starts here and it goes up. So y values are greater than 0. There you go. Alright, I don't need a calculator to do this stuff. Now it says greater or equal to 0. That is false. False. Don't believe that. Number 3, graph the function, state domain and range. Now look at this. I have an x plus 1 here, and I got a plus k here. So this thing translated. Let's figure out. You can draw a rough sketch without the calculator. Watch. The normal, it is a growth because A is 1, B is 3. Normal growth looks like this, right? This translated how much? -1. So this thing moved left 1 and up 2. Let's do the up 2. So now the asymptote is right here. So it's going to, and I just pretended I moved it left a little bit, left 1. Okay? Now it's going to look something similar to this, you know. Now what's the domain? Same thing. It's all real numbers all the time for these. What's the range? That's what changes. What are the y values? Well, they start here, all these coordinates, and they go up. So y is greater than, because it goes up, all this stuff. How much? Where's it start? Well, this is 2. So it deals with this guy right here, the k. Y is greater than 2 is your range. It's actually kind of easy to find domain and range. So hopefully you guys got that. Let's do next type, exponential growth model. We can do this for any word problem. When a real life quantity increases by a fixed percent each year, the amount y of the quantity after t years can be modeled by this equation. Draw this equation. This is not a negative sign. Sorry about this. This is like my bullet points. Bullet point, bullet point, bullet point, so on and so on. Okay, those are all bullet points. A is the initial amount. Write this down. A is the initial amount of whatever you're talking about, whether it be money, whatever you're talking about. R is the percent increase expressed. So if I said, hey, this amount of money increases by 6% each year, then you put 6% here. But the only thing is, which I didn't write down, percent increase expressed has to be in decimal form. Please remember that, because people, if I said 6%, people would just put 6 right here. That is wrong. 6%, you guys should know, is equal to 0.06. That's what would go into this right here. And t to the t power, you know that caret sign means to the t power. So t is t. Keep in mind this, years. You know what I'll get people on? I'll say, hey, after 18 months, what happens to this money? And people will put 18 right here. But t is years, so 18 months is 1.5 years. Pay attention to the wording of problems. Okay? 1 plus r is, this thing is the growth factor, how much it grows by. Okay? So write those things down, pause the video if you have to. Moving on. Let's use this formula. Okay, look at this. 1996, there are this many viruses and other computer security incidents. During the next 7 years, the number of incidents increased by 92% each year. So a lot of numbers in here. We got to decide what to do with it. It says write an exponential growth. As soon as you hear exponential growth model, first thing you write down, y equals a times 1 plus r to the t power, and just kind of put things in. A means the initial amount of whatever we're talking about. In this case, what are we talking about? Computer viruses. What is the initial amount? 2573 is the initial amount of viruses. 1 plus, it says, R is how much it increased by each year. How much it increased by? 92%, which means 0.92 to the t power. So it says write an exponential growth model giving the number n of incidents t years. So actually we're going to leave t up here for right now, because that's what this question wants. It wants t in here equals the number of incidents happening each year. There you go. There's the model that models this idea. How many incidents were there in 2003? That's part 2. See, this is part 1, which we did. Part 2, how many incidents were there in 2003? Okay, well, look at this. 1996 to 2003. How many years is that? 1996, 2003, that's 7 years. So that's where we put 7 in for t. So I'm not going to show you this all by hand. That's what a calculator's for. 2573, 1 plus 0.92 to the 7th power. Put this in your calculator very carefully, and you'll get an answer. Okay? So use parentheses, use the caret key to the 7th power, enter. How many incidents were there in 2003? It'll show us. You could also use the graph to do this. So this is what they did. Same exact thing I did. And see what they did right there. So they put in the calculator, this in their calculator, what you had, and got this right here. That's about how many incidents or computer viruses that happened 7 years later. So you could also use you could also graph it and use the, after 6-7 years, find out how many that is. So, but we did it the better way. Okay, so that's how you find something. Now I could say anything. I could say, viruses, how much they grow per year, or I could say how much this money grows per year. All I have to tell you is a few things. All I have to tell you is I have to tell you your rate increase, your initial amount, your rate increase, and the number of years. That's all I got to tell you, and you can find your answer to whatever you're looking for. Alright, so there you go. Now, example 5 is different. This is the last example. You have to know something else. Let's write this down. Notice this word. It says you deposit $4,000 in the account that pays this much interest. Find the balance after 1 year if the interest is compounded, and it'll tell you quarterly, daily, so on, bi-monthly. I could ask you anything. So that's the frequency, quarterly. What does it mean to do something quarterly? That means 4 times a year, right? So you might want to write that down. 4 times per year. What about if I say, hey, I do this daily. I brush my teeth daily. How many times a year is that? 365 times per year. Okay? That's key in knowing that. Now here's the formula you have to know. A equals P 1 plus R divided by N to the NT power. This is a complicated, semi-complicated formula you have to memorize. I'm not gonna write this up on the board for you come test time. Okay? let me tell you what these are. P is the what we call principal amount, meaning it's like the beginning amount of money you put in to the bank. Okay, that's your principal amount. R is still the same. R is your percent rate increase. T is the same. It's years again, not months but years. But N is the thing that changes. N means number of times compounded in 1 year. That's the key. So that's what this is about. If I say, hey, you compound this quarterly, oh, that means my N is 4 times a year. 4. Okay, what else is missing? A is the amount in your account. Ooh, that rhymes. The amount in your account after T years. After however many years you want to think about it. Okay, so we put money into a bank. We get compound interest, we call it. Compound interest. So as soon as you hear the word compound, that's when you want to use this. If you did not hear the word compound in the problem, remember this, then you do not use this at all. You would actually use the other equation we just used for example 4. Okay? So has to say the word compound, otherwise it's not compound interest. So yeah, you can write right on here, compound interest formula. Okay, write that down. Very important. All we have to do right now is plug in all the numbers, and this is it. Example 5 will be done. So here we go. Let me start over. Quarterly. So let me write this down. Y or A equals P1 plus R over N to the NT power. Here we go. We don't know A, the amount what we will have, but we do know the principal. How much should we start with? 4,000. 1 plus, what was the percentage rate? It says 2.92%. Move that 2 decimal places. 0.0292. That's what people will mess up on right there. Over N. How many times do we do this? Well, that's the first question. Quarterly means 4 to the NT. So to the 4 times T. How many years? It says find the balance after 1 year. So T is actually 1. Just type that in your calculator and you are done, folks. You are done. Okay, so A, this should have been A, your amount in your account is equal to whatever that produces. Be careful when you type it in. Okay, when you do this fraction, I would put this in parentheses and then this and all that. So let's see, type that in, check your answer with mine. Alright, it says the answer is 4,118.09. You see it at the bottom here. Okay? There you go. Now let's go back. Daily. What if I said daily? This will be the last problem I do. So A equals P times 1 plus R over N to the NT. Put it all in. P is still 4,000. 1 plus the rate is still 2.92, 0.0292. Divided by N is the thing that changes. N is how many times a year. What's said daily. So that means 365 to the NT. So 365 times T is 1 in this case. And then you type that in your calculator and you get A equals an amount of money right here. So how much money does that produce? You try it in your calculator by yourself. And I will get to it here. Let's see. That's how you get the first answer step by step. So pause that if you didn't get the first answer. Letter A, quarterly. Now here it is, compounded daily. Type it all in and get $4,118.52. That's how you do what we call compound interest. Okay? There you go. That's section 1 done.